Today, we are going to talk maybe a personal project of yours as well, as part of your personal research, which is called 42D. Maybe the name sounds interesting as well, quite exotic. Can you tell us a little bit more? What is this 42D project?
Sure. 42D is really just a personal project. 42, of course, everyone should know is the answer to life and the meaning of the universe. So 42D is just one small galaxy, and it's the galaxy where we're seeking to explore and find ways so that small groups of developers can develop high value software quickly. That's really been my interest every time I start a new product, a new application. Is there some way we can change the process, change the tooling, change how we think, such that we can be more productive and not end up with big ugly code mountain that we always seem to end up with. That's what 42D is about. And it's really just taking a few things that I found to be really useful over time, trying to now think about them and see if I can bring them to more mature ideas.
So, for those of you who may not know about the meaning of life and all that, I think Dave is referring to this Hitchhiker's Guide to the Galaxy. This term comes from there. So, you're talking about increasing productivity. Is it still the case that developer is still not productive? I mean, technology has advanced rapidly, so many tools, so many advancements, AI, ML, and all that. So, maybe if you can elaborate a little bit more, why do you think developers' productivity is still a challenge these days?
I think because there's just too much stuff. Vendors, it's the API field of dreams. You name it, the next Amazon or Google Cloud, they'll introduce another 40 or 50 APIs. They'll sort them alphabetically so they're easy to use. There's many cases they do the same thing, so you can't even tell which one should I choose. The problem is this, there's so much of this stuff. There's so many libraries, there's so many open source tools, there's so many commercial tools. It's very hard, and they're constantly changing. So if you look, people are, oh no, I'm moving from this one to that one, or I'm upgrading from this version to another. So people are not using them. They're learning the next one. And so it's very complicated. API design and framework design is really language design. And language design is very hard. When you're in a rush and you're producing APIs very quickly to be competitive, you often don't get the same thought, documentation, and examples. So this means that poor developers have to perform experiments. Well, the good news is there's lots of things to blog, because now you have to find how to use React 14 and the latest version of Go and Rust. These languages are actually very nice. Kotlin's a much nicer, simpler Java, but the surface area of these APIs keeps growing, and it varies from vendor to vendor. So this makes things very complicated. The other thing is that my colleagues tell me that we're in an asynchronous world, and that we have to have everything be fully asynchronous to scale and get performance. This is definitely true. The bad news is asynchronous is not something that most programmers are really good at. There is a mechanism due to Eric Marr called async await, which is heavily used, but there's a bunch of very subtle state machines underneath that if you really want to understand what's going on, you need to understand what these state machines are doing. Asynchronous computing is still a challenge versus if you do something like Fred George talks about, very simple data flow. Before you knew about it, there was a thing called data flow diagrams that were very easy to understand. Today, they're very easy to implement on a microservice architecture. But when you start building these asynchronous systems, they're much more complicated. So complicated tools, complicated designs, and very demanding requirements in terms of performance and scale. That's why programming is harder today.
I can see some of these challenges as well, especially for me, learning new tools, learning new technologies. You just finish 1 or 2 years working on this technology and then suddenly, oh, there's a new one. Okay, maybe we should give it a try. And the other advantage is always there's a new job for these people. So you learn something new and then you can jump to another job.
Yeah, absolutely. I mean, it's great for resumes, right? You just
Yeah.
put that new thing on the resume if you can run ahead. And it's a serious investment. So if you really learn it, I mean, everybody else has to learn all those APIs. That's your 10,000 hours that you have to put in.
So you mentioned as a subtitle of this project 42D, you mentioned about maximum value and maximum speed. Maybe if you can explain, what do you mean by maximum value? Is it that the software that we build has maximum value out of it? And maximum speed, do you mean by the performance of the software, or is it the speed of churning out that software?
The speed has to do with the speed of development. If it's high value software and it has to be fast, then it needs to be fast too. It's really the value of the software. in the sense that we want to write as little software as possible and we want it to have as much value as possible. I think that's an obvious thing, but if you actually focus on that, then you think a lot more about how can I build that? How can I build that quickly? How can I have it maintainable and evolve? And how can I try and focus on the things that are maximum value versus often a project gets into all sorts of features and other stuff, which really doesn't matter. So it means that you have to be close to your customer. I think this is obvious, but if you talk to most agile developers and you ask them what the business value of the story is, they say, I don't know. It's just more important than this other one. And they're buried in little tiny stories because they don't really have the big picture. That was really when Kent talked about the metaphor. He was really talking about having the big picture or the really big story in some sense. Because if you understand the key story, then that's where the key value is. And that's what you want to try and focus on and implement and not get distracted into all the details.
And you start with this problem, this challenge with many of the software development teams is that you mentioned the speed actually comes if you form a team that is small enough. You also mentioned write as little code as possible, bring as much value as you can. But the tendency these days is actually to build more and more microservices, build more teams, add more people. There are so many developers these days, the demands, right? So maybe you can tell us a little bit more. Sometimes this is obvious, big is not better, but the tendency for us in this software world these days is just to cram and add more and more.
Oh, I think you can go back to Mythical Man Month, where Fred Brooks, No Silver Bullet, this is the story of the building the IBM 360 computer, is still a great book. He points out that over and over again, we have this nice triangle about resources and time. Despite the fact that everyone who's ever worked in software says, yes, we need a smaller team because we can move quicker, we can focus, we can maintain quality. Management has this panic because of everything rushing along today and the fact that Uber has 4,000 developers and maybe, he only has 3,500, so they need 5,000 so they can have more than DoorDash or whatever. So there's just this desire to throw features out. And this is particularly true because of the web culture. So web-facing applications, people love to pile features in them. The problem is that once you get this many developers, you've just got more and more people basically sticking code onto Code Mountain, and it just becomes a bigger and bigger mess. Even though you've got tooling for testing and things like that, in the end, the only thing that matters is the code. And when code matters, then you get complexity. That's when you get technical debt. The agile developers, in the beginning, everything is great. And then they start begging for technical debt cards. Who created the technical debt? Them. Because too many people running too fast. The other thing is if you have to use a lot of different languages, a lot of different tools, and you have to communicate between more teams, then you've got all this overhead. So you've got the latent complexity plus the accidental complexity, like the APIs are not working yet because it's a brand new API from company XYZ. You just have more and more people and it just piles up. I've not met anyone who has any experience who thinks that hiring a lot more people is the answer for how to get better software, but people do it.
The tendency from the industry is like that. I'm working in a startup, so it's also the same thing. Hiring is always a challenge. We want to hire more and more. We want to hire faster. And we have a lot of competitors as well. People also poaching these kind of people. So it seems like what you're saying is resonating with me as well. Many developers now are being demanded and there are more and more features and code are being written.